Just a minute. Okay. Can you see this problem? That is implement XOR function using macular fits neuron, and we need to consider the binary data. ठीक है? Binary और bipolar data इन दोनों में से एक कोई भी दिया रहेगा आपके क्वेश्चन में. So here we will consider the binary data. Now this is an XOR truth table. You know already. So XOR truth table में you can see here. That is for 0, 0, the output is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 0. Okay, so we'll get an output y. You can see here output y is equals to x1 x2 bar plus x1 bar x2, and y is equals to z1 plus z2, right? So this x1 into x2 bar is considered as z1, and x1 bar x2 is considered as z2. ठीक है। इसमें हमको पहले सबसे पहला स्टेप क्या करना है? सिंपल जो न्यूरल नेटवर्क के लिए हम लोग पहले सबसे पहला स्टेप क्या करते हैं फॉर द सिंपल न्यूरल नेटवर्क? यस। Now these are two function, that is y is equals to x1 x2 bar plus x1 bar x2, and this is this another function जिसके लिए हमको weights find out करना है, जिसके लिए ये output will be true. Okay, so for this there are Z1 के लिए हम लोग ये कंसिडर कर रहे हैं, Z2 के लिए ये वाला कंसिडर कर रहे हैं, एंड ओवरऑल आउटपुट इज व्हाट? इट इज Z1 plus Z2. Okay, so the after this the first step we need to calculate or assume the weights. We'll assume the weights, that is W11. ठीक है, for the first function we'll assume the weights W11 and W21 as equals to 1. Now ये W11 and W21 हम लोग किस लिए बोलते हैं? So you can see, I'll show you the complete diagram. यहाँ पे diagram किधर है? Okay, diagram नहीं है, एक second ना, just a minute. इसके लिए हमको इनपुट आउटपुट एंड हिडन लेयर की ज़रूरत पड़ेगी, बिकॉज़ बीच में हम लोग क्या कर रहे हैं, यहाँ पे 2 फंक्शन को क्लब करने के लिए और एक न्यूरॉन लगने वाला है। सो दिस द कंप्लीट डायग्राम, जस्ट अ मिनट आई विल कॉपी इट। तुम लोग ये तब तक जस्ट अ मिनट प्रॉब्लम लिख के रखो। आई विल शेयर इट। ये वाला प्रॉब्लम लिखो, implement XOR function using Maxwell Pitts neuron. Consider the binary data. And this truth table, you should already know the truth table for XOR gate. ठीक है, तो ये given नहीं रहेगा. This is not given, the table. So you need to consider this table x1, x2 and y, ये आपको पता रहना चाहिए. Then from this you need to um, calculate the or evaluate the equation, that is y is equals to x1 x2 bar plus x1 bar x2. ये कैसे आया है? From this binary data. Okay, जहाँ पे भी 1 है, that case will consider as this. So x1 bar into x2, this will be equal to y. And और एक कहाँ पे equal to 1 है output, where is output is equal to 1 and x1 into x2 bar. तो इन दोनों का addition will give you the combination as output y. तो यहाँ पे सिर्फ x1 होके हमको नहीं मिलेगा, देयर इज आल्सो z1 एंड z2. तो और एक हिडन लेयर यू शुड बी एडिंग फॉर XOR गेट. ठीक है. For this simple case, the output is on. You can see the output is on when there are odd number of ones. ठीक है. So and the output is off for the rest of the data. Now XOR gate or XOR function you cannot represent by a simple or single logic function. ठीक है, हम लोग सिर्फ x1 x2 लिख के आउटपुट नहीं दिखा सकते थे, जैसे हमने एक्स और गेट के लिए हमने दिखाया था, एंड गेट के लिए यहाँ पे बस x1 x2 था एंड आउटपुट y था. लेकिन XOR के लिए there is one more hidden input you should consider. You cannot represent by simple single logic function. So you should represent it by this: y is equals to x1 x2 bar plus x1 bar x2, or y is equals to z1, or function is there. So this is plus or function z2. तो हमारे पास function 1 will be this one, where you will consider Z1 as X1, X2 bar, Z2 as X1 bar, X2, and the whole function, the third function will be Y is equals to Z1 ORing with Z2. ठीक है. So the first function, this is the next step. So the first function will consider Z1 is equals to X1, X2 bar. ठीक है. तो x1 x2 बार में क्या आएगा, 0 0 0 1 1 0 1 1 ये लिख लेना. देन उसके बाद x1 x2 बार को कैलकुलेट करना पड़ेगा. ठीक है. x2 है, उसको नॉट गेट इम्प्लीमेंट करके यहाँ पे क्या आएगा, 1 0 1 0. ठीक है, x2 बार. सो देन मल्टीप्लाई x1 इंटू x2 बार, तो यहाँ पे क्या आएगा, 0 ही आएगा मल्टीप्लाई करोगे तो. any number multiplying with 0 आउटपुट इज 0. सिर्फ इस केस में ये क्या हो जाएगा, 0 का 1 हो जाएगा बिकॉज इट इज x2 बार. तो 1 1 1 into 1 it will be, output will be 1. So z1 will be 1. Then यहाँ पे भी x2 बार है तो ये 0 आ जाएगा and the output is 0. Now after this you need to calculate the net input. तो net input calculate करने के लिए हमको, हमारे पास कौन सा equation है, that is equals to summation x1 w1 plus x2 w2, right? ठीक है. अब यहाँ इस केस में क्या आएगा, यहाँ पे आपको W11 कंसिडर करना पड़ेगा, W22 कंसिडर करना पड़ेगा बिकॉज X1 Z1 को जाएगा, X2 Z2 को जाएगा, X1 Z2 को जाएगा एंड X2 Z1 को जाएगा. सो देयर विल बी W11, W21, देन W12 एंड W22, राइट. वेट्स के नाम क्या रहेंगे, देयर विल बी W11, W21, W22 and W12. Okay. So for the first function you will consider Z1. ठीक है. मतलब यहाँ से एक इनपुट आ रहा है, एक X2 से इनपुट आ रहा है टू द Z1. तो हम लोग क्या करेंगे, the weights will be W11 and W21. Okay. W11 and W21. So it will be equal to whatever the weights is. Okay. So assume both weights as excitatory. Now we'll first case. For the first case we'll assume, हमको क्या करना पड़ता है, हमेशा weights assume करने पड़ते हैं, ये दिए नहीं रहेंगे, अगर दिए होंगे तो use that weights only. Now for the first case we'll assume W11 from X1 to Z1, and from X2 to Z1 it is W21. So we'll, for the first case we'll assume W11 as 1 and W21 as 1. ठीक है. And then we'll calculate the net input. Do till here for the case 1. ये लिखा आपने, have you
Yes, ma'am.
written this one function, first function, using the first function z1 equals to x1 x2 bar, write this table. Okay. After writing this, write this one for the case one. Assume the weights as excitatory and calculating the net input for this, that is x1 w11 plus x2 w21, and you will get this answer 0112. Now, is this output is similar to what we want? This Z1? No, right? यहाँ पे सिर्फ 00 के लिए 0 है, बाकी के लिए it's 111. So ये weights, these weights are not feasible for calculating the exact output or predicting the exact output. So we need a weight updation rule. We need to update the weight. तो हम लोग क्या करेंगे, एक को excitatory रखेंगे and another weight will keep it as inhibitory. ठीक है, so it will be -1. I'll keep W21 as -1 and W11 as 1. So it's like an trial and error. Just change this weight and tell me the answer of the net input. Yes, done. Have you solved for the second case?
Yes, ma'am.
What you are getting the answer?
0 minus 1, 1, 0.
Yes, yes. So, have you got the correct output? So, it is equal to 0, minus 1 will be considered as 0 only, then 1, and then 0. So, you are getting the same Z1, right? Means this weight is the exact weight for Z1 neuron. Then, similarly, you calculate for Z2 neuron. You might be getting this, right? You draw this diagram. Then for the second function, you calculate x1 bar x2. You will get this truth table. Then फर्स्ट केस के लिए हम लोग सेम W12 and W22 को assume करेंगे 1. See whether you are getting the same output. No, you are not getting the same output. Then consider as one as excitatory and another as inhibitory. मतलब W12 को assume करो as -1 and W22 को assume करो 1. Then you will get the exact output. Do this. Have you done for case 2,
Yes,
Aya?
ma'am.
Yes, ma'am.
Yes, ma'am, I am.
Yes, it's 0, 1, -1, and 0, right?
Yes.
For
Yes,
W12
ma'am.
as -1 and W22 as 1. So you are getting uh, these weights and for this output, right? Now the third case, third function हमको use करना है, that is ORing function. ये जो complete output है. So how output is coming? By ORing Z1 and Z2. So this for this function y is equals to Z1 plus Z2, you need to calculate the weights. Weights हम लोग को कौन से weights पे you will get the answer. Suppose this weights will consider as V1 and this will consider as V2. For V1 and V2 weights, suppose we'll consider assume the V1 and V2 as 1. For this weight, are you getting the same answer? Just check Z1 and Z2. तो हम Z1 and Z2 के लिए क्या लेंगे? Again, we'll consider 0, 0, 0, 1, 1, 0 and 1, 1. After ORing, you should get this. That is 0, 1, 1, 0, right? ठीक है? तो Z1 and Z2 के लिए same truth table हम लोग assume करेंगे. Okay, this one. So Z1 and Z2, if it is 0, 0, the output is 0. 0, 1, the output is 1. 1, 0, output is 1 and 0, 0 के लिए this. So we'll assume V1 and V2 as 1, whether we are getting the output. for the net input, it is 0, 1, 1, 0. Means these weights are same or the excitatory weights for the output y. Write this down. Are you getting this or you have any doubt? Write this down.
Sir.
Yes, done.
Yes, ma'am.
Have you written? Okay. Now the next problem. So for W11 and W22, it is 1 excitatory, W12 and W21, it is -1 inhibitory, and V1 equals to V2 equals to 1 is excitatory. So the final diagram you need to draw is this one. ठीक है, तो weights आपको update करने पड़ेंगे for this output Y. Okay, this is your final diagram. This is very important problem for XOR function. Now we'll perform the perceptron problem for and not function. Okay, write this one. This similar to your जो हमने perceptron के and or gate के लिए किए हैं, ये same है. Using the bipillar inputs and targets. नॉर्मल न्यूरल नेटवर्क में हम लोग बायस नहीं लगाते हैं. if bias is given only, then in that condition only हम लोग bias लगाएंगे. But in perceptron we need to add bias for the net input. Okay, for this problem, what we'll assume the initial weight will be 0, that is W1 and W2 we'll assume as 0 initial weight, and your learning rate alpha will assume as 1, and theta, that is the threshold value, will assume it as 0. Okay? So initial weight W1, W2, we assume 0, alpha 1, and theta equals to 0. Calculate the net input. Net input for the first function, that is x1 equals to 1, x2 equals to 1, w1 and w2 as 0. What you will get? Y in. Use this activation function for the net input. ठीक है, नेट इनपुट के लिए क्या हम लोग यूज करते हैं इक्वेशन, दैट इज बी प्लस x1 w1 प्लस x2 w2, राइट. उसमें क्या मिलेगा हमको? y इन मिलेगा. तो हमारा y इन क्या आ रहा है? y इन इज इक्वल्स टू 0. Are you getting y in equals to 0? Since your function is y in is equals to 0, हमारा आउटपुट y equals to 0 आ रहा है. This is the truth table. Y is equals to -1 आ रहा है. Whether that y is equals to f of y in is equals to 0, since t is not equals to y, c in is not equals to y, right? So the new weights are to be computed. हमारा जो ये वाला आउटपुट है t is not equals to your y, right? क्योंकि यहाँ पे 0 आ रहा है एंड हमारा आउटपुट क्या है? -1 है. सो वी नीड टू अपडेट द वेट. हम लोग वेट कैसे अपडेट करते हैं? That is W1 new is equals to W1 old plus alpha TX1, right? Write this down. You will get this W as -1, and -1 for W1 to W2 and B. Similarly, do this for second input sample, third input sample, and fourth input sample. मुझे सेकंड, थर्ड एंड फोर्थ सैंपल के वेट्स बताओ क्या आ रहे हैं आंसर. Okay, done. Are you getting this answer? For the input x1, x2, the weights will be minus 1, and minus 1. For other inputs, you will get this answer. Are you getting this? Okay, just give you attendance. Are you getting these answers?
Yes, ma'am.
ओके ओनली वन कि सबको मिल रहा है तुम लोग इसमें स्कोर कर सकते हो जस्ट ट्राई टू प्रैक्टिस इसमें ऐसा कुछ नया कुछ नहीं है जस्ट यू नीड टू अपडेट द वेट्स and calculate the net input. Next class, we'll see some different problems based on the perceptron and the linear separability. उसमें से दो तीन प्रॉब्लम देखते हैं then we'll complete the second module also. एक बैक प्रोपोगेशन पे देखते हैं where is your attendance. किसी को अभी तक डाउट है
No, ma'am.
okay okay everybody you can leave the meet. I have taken the attendance. Thank you.
Thank you, ma'am.
Thank you.
Okay, ma'am. Thank you.
Thank you.